Let us recall what the words factor, prime, and composite mean. Factors are numbers that divide another number n exactly and therefore do not leave a remainder. Accordingly, the factors of 18 are 1, 2, 3, 6, 9, and 18. Now, let's recall prime numbers. The numbers whose only factors are the number itself and 1 are called prime numbers. Some examples of prime numbers are 2, 3, 5, 7, 11, and 71. But what do you call those numbers that are not prime numbers? Well, the numbers that are not prime are called composite. Clearly, composite numbers have more than 2 factors. Some examples of composite numbers are 4, 6, 8, 9, 10, and 80. Do you recall what is meant by the prime factorization of a number? Prime factorization is the process of writing the product of all the prime factors of a number together with their multiplicity. Click the word multiplicity to know its meaning. Every composite number can be expressed as the product of prime factors in a unique way except for the order in which the factors appear. This is known as the fundamental theorem of arithmetic. It simply means that a given composite number x will have a unique prime factorization of the form p1 into p2 into p3 and so on till pn, where all the prime factors are in ascending order. Let us learn how the fundamental theorem of arithmetic has proved extremely useful in mathematics. Due to the uniqueness of the prime factorization of a number, one can derive all divisors of a number. Also, once the prime factorizations of 2 numbers are known, their HCF and LCM can be found quickly and easily. Let us understand these through some examples. The factorization of 3240 is 2 to the power of 3 into 3 to the power of 4 into 5. And this is unique by the fundamental theorem of arithmetic. This implies that any positive divisor of 3240 must have the form 2 raised to a into 3 raised to b into 5 raised to c, where a takes one of the 3 values 1, 2 or 3, b takes one of the 4 values 1, 2, 3 or 4, and c can only take the value 1. So, some of the divisors of 3240 are 2 to the power of 2 into 5, 2 into 3 into 5, and 2 to the power of 3 into 3 to the power of 3 into 5. You can see that there can be many more combinations which will ultimately give all possible divisors of the number. Look at this example for the second application. The prime factorization of 75 is 3 into 5 square, and of 135 is 3 cube into 5. The HCF of 2 numbers is the product of the smallest power of each common prime factor in the number. Hence, the HCF of 75 and 135 is 3 into 5, which is 15. The LCM, on the other hand, is the product of the greatest power of each prime factor involved in the numbers. So, the LCM of 75 and 135 is 3 cube into 5 square, that is 675. Wasn't that simpler compared to the traditional method?